Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 27, in which I will try to give the concept of variance and standard deviation of a random variable. Now we define variance of a random variable. Let capital X be a random variable whose possible values are small x1, small x2, small xn occur with probabilities px1, px2, pxn respectively. That means probability of small x1 is a value of a random variable and its probability is px1. x2 be another value of the random variable and its probability be px2, and in this way xn be a value of a random variable whose probability is pxn. And we know that mu equal to E under bracket x be the mean of the random variable and whose value is sigma I equal to 1 to n xi multiply pxi. This is the mean of random variable x. Then variance of random variable x is denoted by var x, var under bracket x, or sigma x square, and is defined as sigma x square equal to variance of x equal to sigma I1 to n under bracket xi minus mu whole square multiply probability pxi. Or we may write this as sigma x square equal to expectation E under bracket x minus mu whole square. Now we define standard deviation of a random variable. The square root of variance of a random variable is the standard deviation of a random variable. Since sigma x square is the variance of a random variable x, then square root of sigma x square equal to sigma x, and this equal to square root of value of sigma x square is sigma I1 to n, sigma means summation, under bracket xi minus mu whole square pxi is the standard deviation, where mu be the mean of the random variable x and pxi be the probability of random variable capital X equal to xi, small xi. Now we shall give another form of formula for variance of a random variable. Let capital X be a random variable whose possible values x1, small x2, small xn occur with probabilities px1, px2, pxn, then mu equal to capital E under bracket x equal to summation I equal to 1 to n xi pxi be the mean of the random variable x, and variance of x denoted by var x or sigma x square and defined as sigma x square equal to variance of x equal to summation I equal to 1 to n under bracket xi minus mu whole square multiply pxi, and we may write this as sigma I equal to 1 to n whole square means xi square plus mu square minus 2xi mu multiply pxi, probability of xi, and we may write this as sigma, and this will be equal to sigma I equal to 1 to n xi square pxi plus sigma I equal to 1 to n mu square pxi minus sigma I equal to 1 to n 2xi mu pxi, this equal to xi square pxi sigma I equal to 1 to n plus mu is constant, so we may take it out, mu square sigma I equal to 1 to n pxi minus we may take 2 and mu outside, 2 and mu sigma I equal to 1 to n xi pxi, and this will be equal to same thing, summation I equal to 1 to n xi square pxi plus mu square. Here sigma I equal to 1 to n pxi means px1 plus px2. We may write this px1 plus px2 plus dot 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 plus pxn minus 2 mu. This is sigma I equal to 1 to n xi pxi. Here sigma I equal to 1 to n xi pxi, this is equal to mu, so this is equal to mu, this equal to I 1 to n xi square pxi plus mu square. This is the sum of all probabilities, which is equal to 1. We know this, and this is equal to 1 minus 2 mu square, and this equal to sigma I equal to 1 to n xi square pxi minus mu square. Mu square minus 2 mu square is minus mu square, and this equal to sigma I equal to 1 to n xi square pxi minus mu means here e under bracket x, e under bracket x whole square, and we may write this as e under bracket x square we see that in place of xi, here we have xi square and pxi be same. And for this we write e under bracket x. So here we write for x square e under bracket capital X square minus ex whole square, and this is the required formula for variance of a random variable. Here variance sigma x square equal to e under bracket x square minus e under bracket x whole square, and e under bracket x square is sigma I equal to 1 to n small xi whole square multiply pxi, and we know the formula for ex here, sigma I equal to 1 to n xi pxi. Now we solve a problem. Problem is, in a meeting 70% of members favor and 30% oppose a certain proposal. A member is selected at random and we take capital X equal to 0 if he oppose, and capital X equal to 1 if he is in favor. Find E under bracket X, expectation of X, variance of X, and standard deviation of X. Now we solve this. Since values of the random variable capital X be 0 and 1. Now probability for x equal to 0. X equal to 0 means if he oppose is 30%. That means 30 by 100 means 0.3. P x equal to 1. X equal to 1 means if he is in favor is 70%. 70 by 100, 0.7. Now ex is sigma I equal to 1 to 2 here. xi pxi, that means x1 px1 plus x2 px2. Let x1 equal to 0, x2 equal to 1. Here x1 is 0, px1 means 0.3. 0 multiply 0.3 plus x2 is 1 multiply px2 means x equal to 1, 0.7, and this is equal to 0.7. So ex equal to 0.7. Now ex square equal to sigma I equal to 1 to 2 xi square pxi. This is equal to x1 square px1 plus x2 square px2. Here x1 means 0, 0 and its probability be 0.3, 0.3, 0 square, this is 0 square, and x2 is 1, that means 1 square, px2 is 0.7, and this is also equal to 0.7. Now variance of x. Variance of x equal to, we know this is e capital X square minus e under bracket capital X whole square. E capital X square is 0.7 minus 0.7 whole square. This is 0.7 minus 0.49, and this is equal to 915 here 2 0.21. Now standard deviation of x equal to under bracket sigma x square equal to under bracket variance x, means square root 0.21, and this is equal to 0.458. Now we solve the next problem. Problem is find the variance and standard deviation of the number obtained on a throw of an unbiased die. If a die is thrown, then outcomes will be 1 or 2 or 3 or 4 or 5 or 6. Therefore, sample space will contain outcomes 1, 2, 3, 4, 5, 6. Let capital X denote the number obtained on the throw. Then X is a random variable which can take values 1 or 2 or 3 or 4 or 5 or 6. Since die is unbiased, so outcomes are equally likely. Therefore, probability of each outcome will be 1 by 6. Now, we write probability for capital X equal to 1. If 1, we get value of the random variable 1, then probability will be 1 by 6. Similarly, probability for x equal to 2, 1 by 6. Probability for x equal to 3, 1 by 6. Probability for x equal to 4, 1 by 6. Probability for x equal to 5, 1 by 6. Probability for x equal to 6, 1 by 6. Now we find expectation of x. This is sigma I equal to 1 to 6 xi pxi, means x1 px1 plus x2 px2 plus x3 px3 plus x4 px4 plus x5 px5 plus x6 px6. This equal to x1 is 1, its probability is 1 by 6, x2 is 2, multiply probability 1 by 6, similarly 3 multiply 1 by 6, 4 multiply 1 by 6, 5 multiply 1 by 6 plus 6 multiply 1 by 6, and this is equal to 21 by 6. Now E under bracket x square, this is equal to sigma I equal to 1 to 6 xi square pxi, and this will be equal to x1 square px1 plus x2 square px2 plus x3 square px3 plus x4 square px4 plus x5 square px5 plus x6 square px6. Here x1 is 1, so this is equal to 1 square px1 is 1 by 6, x2 square means 2 square px2 1 by 6, x3 square 3 square px3 is 1 by 6, x4 square 4 square px4 equal to 1 by 6, x5 square means 5 square px5 1 by 6, x6 square means 6 square px6 1 by 6, and this is equal to 91 by 6. Let this is number 1, this is number 2. Now variance of x equal to ex square minus ex whole square, and ex square is 91 by 6 minus ex whole square means 21 by 6 whole square, and if we calculate this we will get 35 by 12. Now standard deviation of random variable x equal to square root variance of x. This is equal to square root 35 by 12, and if we calculate this we will get 1.708. This is the required value of standard deviation of random variable x. So our problem is solved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.